Guys, welcome to day 13. Hopefully you're able to complete these notes and still get some time relaxing for Thanksgiving break, and you're staying safe out there. We're going to talk, just intro a little bit into implicit differentiation. First off, we want to talk about what that word means, implicit, right? It's kind of the opposite of explicit. So explicit is something that is very clear. Implicit is a little bit more hidden. So we're used to explicit functions in terms of y. So here's like what explicit looks like. Y equals sine of 3x squared. Y equals tangent squared of 2x. Y equals 4x squared plus 3x plus 2. You notice that all of these explicit ones are always in the form y equals, because it's very explicit what y is equal to. So we know how to do derivatives there, right? We know our power rule, product rule, quotient rule, chain rule. But we can also do derivatives when y is given implicitly, right? It's not explicitly solved for. So some examples of implicit. We might see something like this. So we might see an equation with y, maybe not solved for y, but y is in there. Sometimes there's multiple y's. Here we see a y squared and a 2y. And when we take a look at these, sometimes our equations here are functions, but oftentimes they're not. They are relations. So we just have to approach them a little bit differently, and we have some different rules. So let's take a look at some rules here. So some rules for implicit differentiation. One, make sure you're always deriving both sides of the equation. We're really doing that in explicit equations as well, right? We're just saying dy dx equals. So we are doing the derivative of the left side in all those explicit ones, but sometimes people forget to do it in implicit differentiation. So we're going to derive. We're going to do the derivative on both sides of the equal sign. Treat x like you would normally treat x. So whenever you come across an x when you're doing it, for example, in this function right up, or this equation right up here, when I came to do the derivative of x squared, I'd simply get 2x. Okay, so we're going to treat x normally. For 3, I want to treat y normally. But then multiply by dy dx. Anytime I come across a y that I'm going to do the derivative of, I do the derivative normally. So example, if I had 3y squared, that derivative would be 6y. But then I need to multiply by dy dx. Okay, we have to do that every time we do a derivative of y. It's the most common thing that people forget to do. Sometimes they remember to do it on some of the y's, but not all of the y's. Okay. Fourth thing, all rules still apply. So all your derivative rules, the rules you use for deriving still apply. power rule, product rule, quotient rule, chain rule. And the last thing that we want to do is isolate dy dx. So after we go through and derive everything, we want to isolate dy dx. So our equation reads dy dx equals, and that will be our derivative function. Okay. Just a reminder, make sure you're not doing your calculus homework in your car, because it's against the law to drink and derive. Okay. So let's take a look at an example 1. Okay, so here we see an equation that says x squared plus y squared equals 16. Now we've seen equations like this before. I know in my geometry class we go over the equations like this. This is if we remember, this is the equation for a circle centered at 0, 0 with a radius of 4. So if we just think about this graph for a second, it would look something like this. So we can see here, this is not a function because it fails the vertical line test, right? Certain x values can give 2 different y values, right? That's the sign that something's not a problem. But we can still, it's still a curve, and we can still find slopes of tangent lines, okay? We can still find slopes of tangent lines. So let's think about doing the derivative here. So I'm going to follow my rules. The first thing is I'm going to make sure I derive both sides of the equation, following all rules, do x normally, and whenever I do the derivative of y, I'm going to tack on dy dx. So it's going to look something like this. So I'm going to start with the derivative of x squared. I know that that is 2x. And I don't have to worry about a product rule here because I have a plus in between. The derivative of y squared then is 2y dy dx. Okay. So because that was a y, think of it like the chain rule, tacking on the derivative of the inside. The derivative of y with respect to x is dy dx. Equals, I got to make sure I derive the both sides of the equation. The derivative of 16, derivatives of constants are always 0. So what I can do now is go ahead and isolate dy dx. So I want to get dy dx by itself. First thing I'm going to do is subtract 2x from both sides. And I'm going to get 2y dy dx equals negative 2x. Then the last thing I'm going to do is divide by 2y. And again, it's helpful here to simplify this. We can think of dy dx as negative 2x over 2y, but the 2's are going to cancel, and we'll get negative x over y. And what this is saying then is for any point on this circle, I can find an equation for the tangent line. I can find an equation for the tangent line there by just plugging in the x value and the y value. Good, let's take a look at another example. By the way, when they ask you to evaluate at a point here, the nice thing about implicit differentiation is they usually give you both the x and the y value. Because we can't just say x equals 2 because there could be 2 different y values based on that x equals 2 or 3 or 4. Okay? Let's take a look at a second example. So a little bit bigger of an equation here. I've got 10x squared plus 4y plus 6y squared equals 20. Again, I'm just going to go through looking ahead a little bit. I don't see any product rule, quotient rule, or chain rule in here. This is simply power rule. So I'm going to go ahead and do the derivative of each term along the way, not forgetting to do both sides. So the derivative of 10x squared I know is 20x. The derivative of 4y, well, the derivative of 4y is simply 4. But again, anytime I'm doing derivative of y, I need to tack on dy dx. Plus the derivative of 6y squared, well, that's 12y. But again, I need to tack on dy dx. And that equals the derivative of 20, which I know is 20 is a constant, so its derivative is 0. Okay. So now I want to isolate dy dx. The problem is I see two dy dx's. Well, that's okay. We always want to get, if there are multiple dy dx's, get them all on the same side of the equal sign and alone. Now both dy dx's are already on the same side of the equal sign, but I want to get them alone, so I'm going to subtract the 20x to go to the right side. Make sure you understand that you're subtracting that 20x over there, so it has to show up as negative on the right side. Some students forget to do that. They move it to the other side, but keep it positive 20x. It has to be negative 20x on the right side. Okay, so now all I have to do is then I see both terms have a dy dx. I'm just going to factor that dy dx out. And once I have that dy dx factored out, then I can divide by 4 plus 12y. And again, that is the correct answer there. However, we should check to see if it simplifies. I see that 4, 12, and 20 all divide by 4. Can't reduce anything with y's, but I can divide everything by 4. So that's going to give me negative 5 over 1 plus 3y. There's a slightly more simplified version for dy dx. Okay. Oops, do you see what I forgot there? This should have been a negative 20x, negative 20x, negative 5x. There's so much going on in these problems, it's easy to lose track, just like I did there. I'm going to pretend like I made that mistake on purpose, but I actually didn't. That was a legitimate mistake I made. But just be aware, keeping track of things and writing neatly is going to be helpful on this. Let's try another example. So here I see 14x squared plus 4xy plus 3y squared equals 2x. Okay, now when I look at this one, there's something different about it, and it comes in that second term. I notice a 4xy. This is a product of two different functions. So I'm going to think of the first function as 4x, and the second function as y. So when I come to that part of my derivative, I'm going to have to execute a proper product rule here. Okay, but I'll start, and I always just work left to right. The derivative of 14x squared is 28x. Plus, okay, so I'm going to do, again, this is my first, this is my second. I'm going to start with the derivative of the first, which is 4. Notice that's a derivative of an x term, so I don't need a dy dx for that part. The derivative of the first times the second, y, plus the first times the derivative of the second. Now the derivative of y is simply 1, but it's not just 1 because I have to tack on 1 times dy dx. Now, I'm not going to write the 1 in here, but I do need to write the dy dx. Again, here I got plus 6y. Again, I need another dy dx equals the derivative of 2x is simply 2. Okay. So just be aware of how that product rule works. The derivative of 4xy ended up being 4y plus 4x dy dx. Okay, I want to group my dy dx's by themselves. Okay, I've got them both on the left side, so I'm going to keep them there and move over the 28x and move over the 4y. In doing so, I'm going to have something that looks like this. Again, moving that 28x and that 4y over, they should both end up being negative. 2 just stays put on the right side, so it stays positive. And again, now I'm going to factor and divide all in one step. Again, I'm factoring out that dy dx, and I'm going to divide by 4x plus 6y. I'm going to combine some steps here. And on top, I'm going to get 2 minus 28x minus 4y over 4x plus 6y. Okay, hopefully you're able to follow my process there. Again, I was just factoring out the dy dx from both terms. Left me with 4x plus 6y, and I just divided that over. Now again, I can look to simplify here. Now when I look in here, I can't cancel out any x's, because there are 3 terms that don't have any x's. I can't cancel out y's, because not every term has a y. But I do see 2, 28, 4, 4, 6. Those coefficients are all divisible by 2. So I can go ahead and just write this as dy dx equals 1 minus 14x minus 2y over 2x plus 3y. Again, both of these answers are correct. The bottom one is the one that you're going to see on multiple choice. However, on free response, you may have to plug in a point, and it may be to your advantage to simplify because it makes plugging in the point a little bit easier to do. Okay. Great. So let's take a look at another one. I think it was the last one. So here I have 3x over 4y plus 6x squared equals 4y squared. Okay. So when I take a look at this one, hopefully you're seeing that this is going to be a quotient rule because I have a function 3x divided by another function 4y. So going ahead and executing the quotient rule, I'm going to do the derivative of the top times the bottom minus the top times the derivative of the bottom. Note the dy dx shows up because the derivative of the bottom function is a function in terms of y, all divided by the bottom function squared, which you put parentheses around that 4y. Right now I got plus 12x equals 8y dx. Okay. Now again, if I have to solve for dy dx, I'm going to have to do quite a bit of simplification here. Let's just take this thing one step at a time. What I'm going to have on top, I'm going to have 12y minus 12x dy dx over quantity 4y squared is really 16y squared. Again, this all stays the same. One thing I might do here, I want to get rid of this fraction. If I'm going to isolate dy dx, I got to get this fraction out of here. But before I do that, I'm going to simplify. I see 12, 12, and 16. Can't cancel out any x's or y's here, but I do see that they all are divisible by 4. So making my life a little bit easier. Save a little bit of time. 12 divided by 4. 12 divided by 4. End up with 3. 3, 4. Now I want to just eliminate this fraction. I'm going to eliminate the fraction by multiplying both sides of the equation by that denominator. And again, I've got to distribute it to both of these. Distributing it to the first fraction just cancels with the bottom. So I get 3y minus 3x dy dx. Multiplying it by the second one gives me a 48xy squared equals 32y cubed dy dx. Okay. So this can be a little bit tedious to do, okay, but doable nonetheless. All right, now I want to get my dy dx's together on the same side. I could do that by subtracting the 32y cubed over to the left side, and then subtracting the 3y and the 48xy squared to the right. But that seems like way more work than just adding 3x dy dx to the other side, so I'm going to do that. I'm going to add this term over to the right side, and I'm going to get 3y plus 48xy squared equals 32y cubed dy dx plus 3x dy dx. Now we're getting there. All right, now I'm going to go ahead and factor out my dy dx and divide. Dy dx equals 3y plus 48xy squared over 32y cubed plus 3x. And again, I can look to see if anything simplifies here. Can't cancel out any y's. Can't cancel out any x's. Can't reduce the coefficients. So that's my final answer. So that's it for today. Go ahead, take these notes and submit them, and we'll practice this in class on Monday. Have a great Thanksgiving break. Stay safe. Stay positive. Test negative. Take care, guys. Bye.